So we looked at how we defined an exponent using integers, and we're specifically using integer exponents. So now we're going to look at the product rule of exponents. Product rule for exponents. I'll start with an example. If we have b, some base to the third power, times some base to the second power. Well, we said b to the third power here was the same as b times b times b. We're going to multiply that by b to the second power, which is the same as b times b. Well, we have in here 1, 2, 3, 4, 5 multiplications of b. That's the same as b to the fifth. And this pattern continues that we can make a general rule. If I have some base, and in this case I'm going to call it a, to the power m times the same base, a is repeated again, to the n, then our problem can be simplified to adding the exponents. Oops, it's not 5, that's n, m plus n. This lets us simplify multiple multiplications. Multiple multiplications. One of the things we're going to use in doing this is the idea of the commutative rule. First, let's look at an example. If I have x to the fourth times x, what we want to note here is when I say x without a power, I'm really saying x to the fourth times x to the first. And my new product rule tells me that's x times 4 plus 1, which is x to the fifth. And let's make it a little more complicated. I'm going to scroll this up here so I can come across. We're going to look at, let's a bit more. Three x y to the fourth times 4 x squared y squared. Well, the first thing I'm going to do is I'm going to take the different parts of this and give them a different color. So all the coefficients I'm going to make red. X's I'm going to make this orangish color. And Y's I'm going to make yellow. No particular reason for the colors, just want to visually separate them. Now, our commutative rule, or commutative property, of multiplication commutative property of multiplication says that the order of the multiplications doesn't matter. Now, if we look at this here, in algebra, we are saying we are multiplying all of these. So this is a series of multiplications. Now, if the order doesn't matter, A times B equals B times C, right? Well, B times A. A times B equals B times A. We can write these in any order. So what I'm going to do here is I'm going to take the same colored things and I'm going to write their multiplications next to each other. And so we've rearranged this, though we're saying the same thing because we're obeying this commutative property of multiplication. Now if we come back and look, 3 times 4 is 12. X times x squared follows the rule of integer exponents we just learned. So x to the first plus 2. Because even though we have x on its own here, got to remember there's a hidden 1 up there. And then in y to the fourth plus 2. Right? And we can simplify this down so that we get x cubed. Let me scroll down so you can see it here. X cubed plus y to the sixth. As all of these things add up, or our integer exponents add up. And this is 2 examples of how we use the product power rule. In the next little bit, we're going to look at a quotient rule and how this works for divisions.